Computer Science and Engineering Colloquia features accessible talks by leading computer scientists and computer engineers from across the region and around the world.
Thank you for coming today. We're very happy to have Michael Nebeling with us. He's a leader in what he calls multi-device interaction. And so this is looking towards a future where we're not just interacting with an application running on a single device, but interacting with applications that run across suites and ensembles of devices. So he looks really at both sides of what will that future be and what's the infrastructure that we're going to need to enable people in developing those kinds of applications, with a particular twist more recently looking at elements of the crowd and how we can leverage that in those kinds of applications. He's won awards and recognition at conferences from CHI to EICS on the engineering side of interactive technology, and ITS, so tables and surfaces. So really exciting to have him here today. Please welcome Michael.
Okay. Thank you, James. Thank you, everybody, for coming. Yeah, so the title of my talk is really reflects the theme of my research, and it is like combining, or the question more, how to best combine multiple devices and use crowds to create more effective, more usable user interfaces. And so I approach this from I build systems that embody my hypotheses, and I test things that way as proof of concept. And this talk will essentially be structured around three of the systems that I've created to explore user interfaces that were partly generated by crowds, that involve lots of multiple devices. And so I want to basically show you three ideas that I have taken from the research idea through to implementation and deployment and studies. And the first of which is we can actually use crowds to support the engineering of user interfaces. And so this is based on a CHI paper from 2013. It's also the project that was really very much at the core of my PhD thesis at that time. And so from that experience, I'll show you more about this, how we use crowds to engineer interfaces this way. And what we get essentially is interfaces that run very well, look very well on different types of devices and individually on these devices. But more recently, I've looked into how to support the interaction when it actually involves multiple devices at a time, so synchronous or simultaneous interaction, parallel interaction with multiple devices. So here I'll show you a project where the main result is actually we are beginning to understand how users want to interact with multiple devices. I've been looking at toolkits and things like that, but really more recently how end users would want to use cross-device interfaces. And the third main idea I want to show you is we can actually combine some of these ideas. We can use crowds. We can put crowds behind devices, and we can create very rich user interfaces. So we can make it possible to write a paper from your smartwatch by putting a crowd behind it. So this is a recent project called WearWrite that I'm going to present at CHI also in a few weeks. And so now I want to get you interested in the problem that I'm studying. So this is essentially a multi-device environment. I'm using a couple of devices to just give you this presentation. Many of you brought devices into this room. And even though we kind of have the technology to get these devices paired up, talk to each other, my argument is, or what I'm going to say mostly, is that we don't really have the user interfaces to make effective use of multiple devices. And I'm exploring this. And so for example, for you now, it's not easily possible to participate in this kind of presentation that I give here. Maybe you want to give me some feedback. Maybe you want to submit a question. Maybe this whole thing is now the way I perceive it is like I'm presenting something to you, but the way I would like you to see it is like this could be a cross-device interface that spans from my computer to your mobile devices or whatever you brought to this talk. And so despite a lot of research into these interactive rooms and things like that, we still face many issues. And there's also this new problem. If we just look at the person sitting here in the corner, the new problem is essentially that us, people, ourselves, we are multi-device environments ourselves. We're essentially an Internet of Things that is moving. And so many of us own and use multiple devices on a daily basis. Maybe this is an extreme case where you really want to use three devices together. And I'll show you some of the examples of the interfaces that I've created. The interesting thing is when we now move to this new kind of problem, it is that we cannot instrument the environment, or we don't want to instrument the user too much, or we don't want to add hardware onto users. We basically just want to make it work with the devices that they carry. And this means that many of the techniques that have been presented in the literature do not really apply here. And so we need to come up with new ways of making it possible to interact with multiple devices. And so I will argue in this talk that the larger problem is actually how we program interfaces, how we teach user interface design, and what we have in the toolkits that are available to us to create user interfaces. At present, user interfaces are typically created by designers for the average user and the average device. And so the first step is when we think about a user interface, it makes a big difference whether we're designing for desktop or for mobile. On many levels, not just the user interface, but also in terms of technology, software, operating system, software, development kits, etc. So what we'll end up essentially doing is, even though we have, like we're the New York Times, let's say, and we know that our users want to access the news content, we actually have to create lots of different versions of the same interface. We have to not only create them, we have to maintain them. Right now, the New York Times offers 8 different applications that you can download to consume their content. So this is actually very costly. And so what I'm actually working towards, and what if you look at my research, and I'll show you some of this today, is like towards this future where we actually essentially create user interfaces that can very flexibly run on these devices individually, but they can also span multiple devices. They can actually make use of an ecology of devices. And my goal is really to enable interfaces to seamlessly grow and take advantage of the additional devices, kind of to next them if they are there. And I'm actually investigating novel, at different levels, novel approaches that involve both, the system developers, but also the users. And so it's like an end-to-end kind of research program that I'm running here. And I will not have the time to go into all the kinds of things that I've tried out to explore this. But essentially, I've taken this route where I'm actually looking at what are new design methods and tools to actually support the creation of user interfaces that are more flexible. I often create new platforms, both for experimentation and research, but also enabling platforms for technologies that can then build on these frameworks and toolkits. And I've also experimented quite a bit with crowds and how to actually make use of all of you here in the room to help me create a better user interface by involving you in the design. And so my current research questions are essentially how can we adapt data-driven, and I'll show you some of this, what I mean by this, data-driven and crowdsourcing techniques that we have studied in some sense. How can we adapt them to the design problem? How we can get crowds involved to support designers to create better and richer multi-device interfaces. And the other one is also, at the other end of the spectrum, I'm thinking about the users, and how can we actually better support users in device-to-device interaction, make it easily possible to start a task on one device and transition it to another device and back and vice versa, and to really easily facilitate these multi-device applications. I show you lots of examples today, lots of videos, so I don't have like the full answer to all of these questions, but it's really an interesting space to explore. So what I'll do now is I'm actually going through these 3 projects, and I highlight the ideas, each of them. So the first one is CCTouch, the idea of actually adapting interfaces to multi-touch input and driving the interaction this way. So right now, if you wanted to create a multi-touch interface, the first issue you have to deal with is there's so many different kinds of multi-touch devices out there. It's really difficult for designers to anticipate which devices users will be using and what are the differences when it comes to the form factors and things like that. And so what you do right now is an iterative approach. You try out, for example, an interface like this and realize, OK, the font size here is probably not optimal. So we create a new version of this where we think maybe this is a better font size. And this is not perfect design, what I'm showing here. But sometimes it's really like experimentation in terms of what's a better pixel value that you want to insert here to actually create a new interface. And is this then now a better version than this? And now the question behind the research project that I'm going to show you is, what if we could actually crowdsource the adaptations? What if you could just know what's a good font size for different kinds of devices by observing users and actually making use of the data that we collect this way? So I'm going to show you CCTouch, which is essentially both a method and a tool. It's an adaptation method in some sense, and it's a tool to make it possible. It's a 4-step method. I'm going to walk you through this method. So the first thing you do is actually you take an interface that at this stage is not very well adapted to different kinds of touch devices. It's often just a desktop interface. We embed WCTouch in this interface. We observe what users do with this interface. WCTouch collects lots of data. I'll show you the two main metrics that we're looking at. And so what the user here was doing is like trying to activate a link, and these links in this kind of test interface don't do anything. But then a common workaround for us is actually to zoom into an area. When the design isn't right, we zoom in and we counteract the issues that way, and then we are able to actually interact and execute the link. So the first thing WCTouch is actually observes these interactions, and it does this. We always have to keep this in mind for this project. It does this on all kinds of different devices for different kinds of use contexts. So WCTouch was specifically studied in the context of smartphone and tablet usage that vary in terms of form factor, and then also the use context in terms of how users orientate the device when they actually use it. And so it actually collects lots of data for this. I'll show you. The first thing we can do is actually we can visualize the raw data that we collect. So we can do this directly, but we can also make it make better use of this data by actually breaking the raw data down into the actual components of this web interface that are involved, and actually highlighting here the menu on the left that was really an issue. And so we do this just based on the data. So WCTouch essentially instruments the interface. And an interesting question is, how do you collect data on links that were not successfully activated? I mean, clearly we can track all kinds of interactions that were successfully executed, but how we do it in this case. So what we do is actually we instrument the areas behind the link. You see it here highlighted for the Chi13 website, highlighted in red. So we essentially create larger touch areas invisible to the user behind each link. And whenever there's an interaction happening with these links, like here in this case with the blue areas rather than the green areas, we know approximately users wanted to interact with this component, but actually missed it. And so we can count errors. There's a certain cost involved if they have to, navigate back and things like this. So we can get to this data. And the other thing is what we observe clearly is that people zoom in to counteract the issues. So the zoom level we also track, and we track this for different components in the web interface. We essentially build this kind of interaction log that you see here on the left with the visualized raw data. We see the viewports. We see where the areas where people interacted with the most, where they missed links, etc. And then we can actually, through log analysis and some thresholds, we can actually determine which are the components in this interface that really receive a lot of interaction, but also face a lot of issues in the sense that people have to zoom in a lot. And so we can collect this data, again, for lots of different devices, different use contexts. And so what we can then do is actually we can make use of this data. Now this is the interactive, the crowd programming, from my perspective, aspect. We can actually formulate an adaptation rule like this one. We can see if for the particular device on which this adaptation rule is now executed, if people half of the time miss the links that they wanted to interact with, one thing we could do is increase the font size. That would already improve some of the, in some sense, it would introduce some new issues. I'll talk about this also. But it would essentially make it easier to activate a link. And so we can actually, we don't know what the good font size is, but we've observed that people on average zoom so and so much into this interface. So there's something about this zoom factor that we can use, and we can actually generate a user interface that adapts according to the data that we've collected. And we treat this data basically as a user needs kind of data that drives the adaptation. What you see here is on the right, then the adapted interface just for one of the orientations in smartphone. And so we ran studies. We actually structured the study in multiple parts. There was a remote user study component, but also a lab follow-up. In this study, we wanted to find out what if we take the desktop interface that was already there for Wikipedia, and there's already a professional designed mobile interface. How does our crowd-generated, crowd data mining, that's what we used here, to actually generate a user interface based on the adaptation rules that I just showed you. How does an interface like that actually fare against something that was professionally designed, clearly more advanced adaptations than what we did, but how does it fare? The one in the middle was, from our perspective, very cheap to do because we just had to observe for a certain amount of time and then make the intervention and supply these adaptation rules. And so there's a series of studies that isn't described in this Chi13 paper. But what we essentially did is we interviewed 6 experts, tried to understand from them, when they look at the desktop interface, the desktop version of Wikipedia, how would they design a better mobile version? And clearly they had some more advanced ideas, but they had a very good overlap with the issues that WCTouch also detected automatically by just observing the interactions. The interesting thing is now, how close did WCTouch actually come, the crowd-generated version, come to the interface that was professionally designed. And so here, the differences that we observed were not significant. The users rated the reading experience as a very similar reading experience. If we make the adaptation that we make the font size larger, it essentially, we reduce zooming, but we increase the amount of scrolling. The document grows longer. So we were interested in whether this is a new issue now that we introduced. So but the feedback that we got, less zooming is appreciated. Clearly, you don't have to zoom in. You avoid the horizontal scrolling. What you essentially have is vertical scrolling. And this is something that we can easily do with the one hand. So increased scrolling was not perceived as an issue. More generally, if I look at this work, it clearly falls into this space of thinking about adaptive interfaces and adaptable interfaces and who should be in control. And there are lots of researchers have looked into this. Yeah, do you want to interrupt me? Okay.
If you go back, what other kinds of adaptation rules can you do with W3Touch? So we saw a bunch with sort of changing the font size.
Yeah.
What are are there more complex things that you can do?
So we went this extreme. What can we do with very simple rules? Can we already achieve an improvement? What you will probably argue is so let's say you can do everything you can do with CSS because this is essentially just JavaScript, CSS, etc. Right? That addresses your question only from the functional point of view. It's also like, what should we do? Maybe is the interface on the right it's more professional. It has more advanced adaptations. We could do this, but the key idea here was really to bring in the data and maybe with minimal adaptations already achieve good results. And what I can say here is that in terms of the usability and the task that we studied, which was mostly reading, we achieved good results for W3Touch for just using very basic adaptation rules. If you talk to the professional designers, they would come up with much more advanced adaptations, but then you would need to experiment with those as well. The point I wanted to make is that W3Touch is really exploring the space where we have seen approaches where the system is fully in charge. We have seen approaches where the user is given all the power. We have seen essentially powerful system where the mixed initiative approach is like trying to find a good combination of the two. And W3Touch now explores this new space where we actually put a crowd into this kind of ecosystem in some sense. And W3Touch is more like it's like a developer tool supporting developers. But I've also in another project looked into what if we just allow crowds to give them a direct manipulation interface, essentially relay out web pages. That doesn't work so well on small touch devices, but it's an interesting and viable approach as well. So this is an interesting space to explore also, just how to involve crowds in the engineering process of user interfaces. This was the first idea I wanted to show you, and the interfaces that we can generate this way. What we have achieved then is actually interfaces that adapt very well to different types of touch devices, just by observing how users interact with the interfaces and counteracting the issues. Recently, I'm really more interested in taking this work further along the direction of allowing cross-device interaction. So cross-device interfaces can be useful in settings where, for example, it could be interesting here, but let's say we are mobile and we have smaller devices with us that you wouldn't want to book a plane ticket somewhere or make a conference reservation because you feel constrained. So then a cross-device interface could essentially give you more screen real estate, even though you just have a smartphone and a tablet. So combining multiple devices for more screen real estate is a scenario, is an idea you will see a lot in these interfaces. But also making better use of devices and working around the individual limitations some of these devices have. So a smartphone can easily become a keyboard to a smartwatch. In settings where voice input is not really the thing to do. And then what you also see a lot and what has been investigated in research is also remote control metaphors around cross-device use. And so when I started in this space, the first thing I was interested in is like, okay, and there has been some research already in distributed user interfaces for some time, but I felt like we really lack the tools still. And so Kai 2014 was like everybody had the same kind of idea. We need new toolkits. I was in this cross-device interaction session. We saw like 3 toolkits that essentially all of them did the same, in some sense, the same thing. XD Studio was the one that I presented. XD Studio is essentially a visual GUI builder, but it's a visual DUI, distributed user interface builder. What you can do with it is like essentially take a source interface and design how you want to distribute it according to different devices that you have available. They're interesting. So this is the visual part. There are interesting concepts around it. We introduced the concept of a distribution profile. What goes into this distribution profile? You essentially can model different kinds of devices that are involved and then make decisions about how the user interface should be distributed. What you will see in 2 videos I'll show you in a second is and it's very seamless. So I just wanted to say it first. As the designer distributes this user interface, they quickly switch between designing and using the interface just to getting to some of the components that would only be available in some state of the interface. And at any time, you can switch between the authoring modes. You can switch between an authoring mode where you essentially do create the whole distributed user interface using one device by simulating other devices. Depending on the screen real estate, it can make a lot of sense. And when you start from scratch also. But when it comes to testing and debugging, the cross-device authoring mode is an interesting one because it allows you to actually involve the target devices that you're designing for. So one way to look at XD Studio is that the authoring environment itself now is a distributed user interface, and that can be very powerful. So what I show you first is let's say we wanted to design, I wanted to give you a cool presentation here, and I knew that there would be additional devices in the room. And so part of my interface is clearly the slides that I wanted to present to you, but I also wanted to allow you to connect to this presentation, use your mobile phone, and submit questions to me that maybe we can answer later on. So the designer here just quickly created a distribution of the source interface. Tiano here switched between design and use and trying it out. And what you see is clearly there's a lot of mirroring at this stage because that's what you want when you present a presentation this way. So the audience can follow along, but the presenter is in control. And so that's one way to do it. And the other one is at any time in this authoring process, whenever Tiano feels like it's better to actually continue to transition the task of designing this interface to another device, she can easily do this. So she just moved the component onto the tablet, and now she's making some decisions about this interactor and how it should look on this kind of device. And so there are some interesting concepts in XD Studio, but it was really also a foundation for my start into this space. And I created a family of systems, clearly research prototypes, working prototypes, that I presented at different technical conferences, where we really tried to look at, okay, so this is a GUI builder, XD Studio. What if we put a Kinect in the middle? What can we do in terms of cross-device interaction? Clearly, there's a lot to do about the way we move information between devices and things like that. So that's XD Session. And more recently, I've looked into how we can actually take some of these concepts that we see at the system level, toolkits level, how we can actually make them part of the browser. And so at the same time, what's been happening in the research community is so XD Studio was not just good for my own research and for funding some of its research, but also it had a little bit of an impact in the community in the sense that some of the concepts that I didn't really go into too much detail here actually were picked up by the community. They now form an essential part of a range of cross-device toolkits and frameworks that were presented. More recently, focused more around smartwatch interaction. But the ideas are the same. Still, the problem that we have, if I can go back for 1 second, the problem that we have now created lots of cool toolkits. And clearly, they're not just research prototypes. You do see some of the ideas at least being picked up in industry and in products. And so there will be a new wave of these kinds of user interfaces where we can use multiple devices. But at this stage, for the studies that I wanted to run, it was really difficult for me to get access to cross-device developers. This generation of designers and developers doesn't exist at this stage. So, but we have users that potentially like to work with cross-device interfaces. And so I created this. I thought it was good to have a browser. Maybe if we can take some of the concepts that were previously integrated in the toolkit level and raise it to the level of the browser, where we can then make them accessible, the minimal set of tools accessible to end users, to non-technical end users. What would they want to do? Okay, and so I'll show you here XDBrowser. So this is a cross-device interface, and I'll study it in more detail in a bit. There was Gmail. This is a way of interacting with the Maps interface, where you actually process the different levels of the information on different devices. And here's a remote control. The kind of thing I would want to do right now is actually remote control, maybe from my phone, this interface. And this is a YouTube video. So XDBrowser is, I'll show you how you do it. So at this stage, what the user can do is actually they can reconfigure the interfaces that they use a lot, and they can adapt them to their personal preference when it comes to multi-device use. At this stage, it's still a little bit experimental. We use this primarily to run a study. It's not the final version of the browser that I envisioned for this browser, but it was very useful to study what you can do. So the user now moved some parts of this interface, and the left now is this device that I can dedicate to checking when new emails come in, and then I can actually, when I feel like answering this email, I can actually move to the tablet, and so these would be synced. So we ran a study with 15 end users across a range of interfaces, so popular interfaces, so something that resembles Gmail, YouTube, Maps, something close to Wikipedia, and a slideshow interface. And we wanted to study what kinds of cross-device interfaces would they create. Clearly, in the literature, we have seen what's possible with the toolkits and what's feasible, but is this what is desired by users? And so we have a collection of 144 desirable multi-device designs now that we then started to analyze. And I want to show you some of the patterns that we extracted from this. So we have now an initial set of 6 cross-device interface patterns. Some of them will need a bit more time for me to explain to them what they mean. But popular ones are, for example, where you dedicate one device to really perceive information and another one to really go into the details. That's very useful if you have one device just as a reference point. What's the email that I'm answering? I forgot. Okay, quickly switch and things like that. So that's one way of using multiple devices, more asynchronously. Or to actually dedicate different roles to devices. So people have different preferences. That's what we clearly saw in the study. But it was common to use the larger device, the tablet here on the right, for input, just because the virtual keyboard is larger and more accessible in some sense. And so we can create cross-device interfaces this way. But as I said, this is not right now I'm pushing it into, like building on these results, I'm pushing it into a new version of XDBrowser, where some of this can be done automatically. Here what you see is by default, the cross-device interface will be duplicated, and that's not the most useful. But as the user starts interacting with this interface, double tapping into a region, it takes one of the patterns. It automatically segments the user interface and extracts the component that we are most likely to be interested in, and then also just on the fly generated the cross-device interface. And depending on which components I interact with, I choose a different pattern. So that's one direction I'm taking this right now. And the other one is we could apply some of these things directly at the operating system. Here the user just mirrored the screen onto the smartwatch to continue the interaction. Here the user decides to start a task.
2 to 3 p.m.
Start a task on the smartphone, switch to the smartwatch for voice input, and continuing the task on the smartphone. And here the user mostly wants to send a quick reply. But then rather than actually using voice, for some reason it's not possible in the current setting, they just answer and use the smartphone as a keyboard. Now, this video was very fast and maybe to some extent also confusing. But the main thing here is I wanted to give you the sense of the flexibility that we can support when interacting with multiple devices in this way. So this was this part. And now I wanted to show you a project where we are taking a little bit of an extreme in multiple senses, and it's also a more controversial project in some sense. So we created a system where we have essentially a crowd behind a smartwatch. And we wanted to explore what we can do with this. So the WearWrite project supports cross-device interaction from an individual to a crowd of people. And so rather than actually trying to, a lot of people in the research community currently look at novel interaction techniques for providing input to really small devices. And they come up with nice interaction techniques, but they also invent new hardware. We wanted to get this going on an unmodified device. And the main idea here is really we span this cross-device interface from the smartwatch user to the crowd on the other hand. And we support writing on a smartwatch. We can actually write a research paper on a smartwatch. In fact, the first version of this project is a tech report that was created from actually me using a smartwatch and a crowd of people writing this way. So this is an interesting paradigm. I want to dive a little bit into this. So what can the smartwatch user do? In this case, specifically designed for writing, they can give writing instructions as audio, or they can also be recognized. You can choose. And the crowd, on the other hand, will see these instructions. The crowd can produce edits in an interface that I'll show you in a second. The most important thing is you don't get a notification every time something happens in a document. We wanted to be very careful about the notifications we send to the smartwatch user. We wanted to be smart about sending only major edits for approval. There's also a way to actually interact with the crowd, to have a conversation with the crowd through a question and answering interface. The crowd, on the other hand, we wrap around a Google Doc. We don't reinvent collaborative editing. But we put in a task interface that actually directs workers through this complex writing task. We decided to give full access to the full context of the document rather than extracting snippets and just letting workers work at this level. So there's clearly there are lots of interesting questions how to maintain context for workers and things like that. What they do get is some feedback in terms of like what's the specific task they should be working on, how much time they should spend on this, how many other workers are currently working on this kind of task. And they have this question answering interface. And the interesting decision we made here is like, it is less likely for workers to leave a question and wait for a response from you. So it's more likely for them to leave a question and just, OK, I've done my bit. And if somebody else comes in, or themselves at a later point, they can continue this task and benefit from this conversation that at that time would have happened between the smartwatch user and the crowd. The system always has generic writing tasks. So they work at a very abstract level. We start from a bulleted outline. We produce a prose kind of document. So a simple task would be to find a bullet point and turn it into a sentence. Later on, we walk the hierarchy. We work at a higher level of context. We turn sentences into paragraphs. We turn paragraphs into something that makes sense. And if there's anything else in the document that needs work, please change it. But these are just the system-generated tasks. The smartwatch user at any time, they will get informed about the edits that are happening, and they can actually specify new tasks. So, for example, merge the first and the third sentence. That's something they would want to do if somebody works at a very micro-management level. Other tasks would be to make something sound better. So that's a very, not the most specific task for workers. But so we've given it to smartwatch users. And so here, what you see is also you don't see what's happening on the right. I think I blurred it out a little bit because what you see is here a lot of interaction that's happening. So what happened was we had 7 smartwatch users writing individual projects over the course of a week. 3 of them actually created introductions to their Kai paper using WearWrite. And you had a crowd of workers actually doing some of the editing, and not being the authors, but actually working on explicitly on these writing instructions. And so the system observes some of these and make sure that we don't ask for every change to be approved by the smartwatch user. So we have heuristics in the system that filter these changes, and the smartwatch user will get a thumbnail of a major edit. They can explore the edit on the watch, and they can approve or reject it. This is a blog article that somebody created over the course of a week on a chess tournament in which they participated. Some of the takeaway numbers here is like on average, our 7 smartwatch users, worked with 29 workers, so there was a lot of activity happening. I'm not sure whether you've ever written a Google Doc simultaneously with 29 other people, but so there's a lot happening. So a system like ours really supports and is really necessary to make some of these decisions on behalf of the smartwatch user. The other interesting bit was that even though there was a lot of debate about the writing quality with the crowd and whether it matched your writing style and things like this, so we did follow-up interviews, nevertheless, smartwatch users over the course of this week had a very high tendency to accept the edits. So 98% of the edits were accepted. We paid individually of rejection or acceptance of these edits. We paid the crowd workers an okay kind of salary, if you want. So what we've seen through this project is with a paradigm like WearWrite, we can actually transform smartwatches into content production devices rather than just content consumption. We could enable a lot of interesting use contexts. Some of them are maybe a little bit tricky. So clearly, people use our interface while waiting in line, while waiting for a bus, while riding a bus. But somebody also were driving a car from Chicago to Pittsburgh because they felt it's a very long drive and they wanted to get something done writing, and they had some good ideas on the way. There was this clash of different writing styles, both between different crowd workers, but also between the smartwatch user, the actual author of the document. And so we debated this, and we have some interesting ideas of how this could be improved in the future. But the consensus was it's a good starting point, both as a system, as a first proof of concept. We didn't get everything right, but we enabled this cross-device experience, and you can actually now write from a smartwatch if you want to do this. And so one of the smartwatch users said it's something to jump off of, and that's powerful and useful. So they were actually very appreciative of what the crowd did. So I wanted to run you through these projects. They are connected in different ways. They involve multiple devices and crowds to support the creation or even the interaction with these interfaces. These are 3 examples of the research that I've been doing and how I've been trying to push the agenda. And more specifically in the future, what I'm really interested in is, clearly I've shown you mostly standard touch devices that all of us are familiar with. I want to push for an agenda where the goal is really to make user interface design natural. And what I mean by this is, first of all, when we design more natural user interfaces involving multimodal speech commands using Kinect, etc., the design process, the development is actually not natural. It's very much desktop-oriented. If I develop for a smartwatch right now, I do this on the desktop. There's a lot of trial and error, debugging, etc. This is not the most natural kind of user interface from a developer perspective. The community has really focused a lot on how to improve the user experience, but not so much on how to improve the developer experience in this space. At the same time, when I say making user interface design more natural, I also want to make it more natural for users to be designers. And so this means that we actually want to create new tools that make it possible for, like XDBrowser, that make it possible for users to create interfaces that they may desire. The other thing is clearly a stream of research into powering interaction with crowds. Here the idea is really to when we can't really create the cross-device interfaces just because of the lack of devices, and the only device that we really have is the smartwatch, but the smartwatch by itself is not really smart. What if you could fill in the crowd behind these devices? So I find it very interesting to think about having a crowd in my pocket and what I can do with this, rather than just the device by itself. And so that's something I want to explore, and I'll show you some examples in a bit. And so all of my research involves data. That is data that's collected through the studies, just through observing interaction with an interface, and clearly also the feedback that we receive from users, but mostly the interaction that we collected. And so I really want to build a repository of these observed real-world kind of user interactions that would be very useful for people that design, for example, gesture-based interfaces. I mean, clearly we have we lack design guidelines in this space, and so it's really pushing towards more natural user interfaces. So clearly what we'll see now, and what's happening already, is we see many new interactive technologies out there. So I go to the major conferences in HCI, and they show you the coolest and latest interface, but how would I really design these interfaces? So what are effective methods and tools for creating new interfaces using these technologies? And then the next question is also, how do we adapt existing interfaces, right? I mean, whenever you introduce a new technology, like a smartwatch, what does this mean for all the interfaces that we have so far? How can we adapt to these? And do we need to adapt our design practices as well? And I would say, yes, we need to invent new ways of designing more natural user interfaces here. And so I want to explore techniques that increasingly blend the digital and the physical world. And if you're still a bit surprised why I'm talking about natural user interfaces suddenly, because that's the goal. I want to make it both more natural for users but also for designers to create these interfaces. I show you one example here. This is a cross-device interface where the user can actually send content from one device to the other. Very pronounced gestures. It's a very crude interface at this stage. It's also a multimodal kind of interface. Now we change the mode. We can annotate this kind of scrapbook that we have. The user can switch modes back and forth. And so this is an example where I use some of the cross-device technology that I showed you and combine it with a more natural kind of interface like Kinect. And I'm really interested in integrating such technologies in design. So when I put on the next HoloLens, how would I actually create a new user interface using this technology? So to start exploring these things, I've really made an effort to create methods and tools that would allow designers to collect data, to process this data and understand this data. For example, here, clearly what you can do is you can observe gestures, you can do some kind of basic video analysis, if you will, which is currently rather manual. But Kinect analysis is really a tool. It's both a method and a tool that allows us to record, analyze, visualize, and share complete multimodal interaction sets with the community, with other designers, etc. What you can then do is build some visualizations on top of this. So here, a very simple one is a heat map following this kind of like flick gesture. And that's interesting. It gives us some reference points of how we could actually implement a better gesture, maybe to detect like a better gesture recognizer. And the other thing you can do here is also we have a scripting language here. I wanted to zoom into this part where the user can now very quickly specify like a natural language query. So we want to look for a skeleton that performs a certain gestures in this kind of data that we've collected from lots of user studies and things like this. Where let's continue with this. Where when we execute it, what we'll see is actually we execute this now, this query, this expression that I just showed you, and we go through the data that and actually what we want to do is in this case we actually record a new example of this kind of gesture. And so we already have like a live kind of tool that allows us to detect some of these basic gestures. It is also interesting when it comes to going through recordings that we have collected and actually supporting some post-processing of this. So for example, here we had lots of users invited to our lab, demonstrate some interactions they wanted to do with a multi-modal web browser using Kinect. And the first thing we want to do is like go through this data very quickly, visualize it in a way. So what we see here is like potential areas where we've observed some interesting gestures that we want to use in this kind of system. So the way I want to achieve this kind of, I've made a jump from mobile to Kinect, but that also reflects who I am, because I'm really this interaction techniques guy that throws lots of different technologies around and actually combines them in interesting ways. And I want to create this experience also as a lab, as a living lab where my students and I can actually work together on this, where colleagues can come in and help us improve these interfaces. And with the technologies that I've shown you today, one thing we could actually do is I could just paste the web browser onto the wall like here and continue interacting with it, continue a task that I've started, a browsing task that I've started on another device. That is possible when you combine some of the techniques that I've shown you today. And so this really concludes my talk. I look forward to pushing this kind of systems-driven HCI research and to really doing this here at the University of Washington. And I would be open and hopeful for your questions now. I would like to answer those. Thank you. Yeah.
So you might have said this, I might have missed it, I'm sorry, but how do you define a natural user interface? So what makes something more or less natural in your?
And that's a good question. And so the way, I guess what people would normally argue is if there's a natural mapping between what you would expect, like the system behaves as you expect it. For the system to get it, I mean, some people put it as like new modalities, it's touch, gesture, and speech, multimodal. What I'm really aiming for is a user interface that doesn't need a lot of training. The user will just know how to interact with it. This is to me then a natural user interface. It just feels natural to interact with this. But it's not the definition that you would read when somebody explains what a natural user interface is. Like Dan Victor, A Brave New World, you would find a different kind of definition. But I'm really just working, to me, a cross-device interface can also be natural if it's clear to users how they can create it, how they can put these devices together. If it's just maybe on the other hand, right now, all of the examples that I've shown you is probably not what you would want to do right now. You feel like maybe this is I can't see myself using a smartwatch and a smartphone in this kind of setting. But my goal has really been to enable this through the technology and to study this, how it could be used, and hopefully it will be a natural user interface to you in the future. Yeah.
I have a question about the crowdsourcing one where you let the crowd decide that the text, it was fine if the text had to be scrolled forever vertically. But when I look at that, I see that like 3/4 of the window is junk, and there's this little narrow column of text that I want to read in a very large font where I can't speed read anything. And it just seems like it's maybe everybody's happy to scroll with their thumb, but it seems like a very ineffective way to read text.
Mm-hmm.
How does this play out? I mean, it's one thing to be popular, but it's another thing to be effective. And I'm trying to figure out where that lands in that balance.
Yeah. So you were referring to this example here with the one in the middle, and the question was like really, I mean, trying to paraphrase the question. How well does this interface really work? Is this not the solution that we want? So the first thing I want to say is like here are the tasks that we really studied with. So these are tasks that are mechanical. You need to get to this interface. We ask users to click links that they would interact with. They would need to find things in the text, like a link here specifically, but also that involved reading and navigating within this document. And so these are the tasks that we use to collect the data. That was what I'm saying here. It's not a usability study of Wikipedia. It's really to give you tasks, interaction-oriented tasks, and that we use to obtain the data that we received. And so if I go to this, to this interface. Now, the data that we collected, the usability data, we measure time. There are different metrics that you can apply to say now that this is a good interface. One thing I think your question is also hinting at is aesthetics. Like the one in the middle is something that, okay, it arguably involves it requires a lot of scrolling, but it also doesn't look as nice as the other one. So I think your question is maybe also going into that direction. And I would agree with this, but again, the data that we collected for the tasks, and maybe we were not maybe the tasks that we studied are not all the tasks that you want to do in Wikipedia. But the data that we collected is, in essence, the usability that we measured that way is matching the usability of the mobile interface. So another question related to this, and maybe you were also hinting at this, is like, what would a professional designer now say about the crowd-generated interface that we generate in the middle? So I'm just giving you this question because I receive a lot of this criticism, so I think this is a very good question to ask from the point of view that the person that's asking the question. But if I show you the data that tells me that this is a usable interface for the tasks that you would commonly do with an interface like this, then I would say the users themselves actually provide sufficient support that this is actually a usable interface. And it may, what I'm beginning to see with some of the interfaces that I've created this way is like maybe it also questions some of the design guidelines that we have out there. Maybe we need new design guidelines, maybe we need to adapt them. But it's an interesting space to.
So what that would seem to imply then is what people do on Wikipedia is they don't actually read the information, they click on the links. Because that looks like a terrible interface for actually reading the article.
I think
it may be very optimized for finding links to click on. Is that, I mean, yes, I understand your data drives you in this direction, but it seems like it's a strange direction to drive to.
I would say maybe, I mean, we started the iteration of this interface at this stage. Like after 2 weeks, we have this interface, right? If we now, through continued observation, determine that actually a lot of people still zoom into this text area in the middle, so maybe they, I mean, there are two tasks you want to do. Maybe quickly find something. I agree this is not so easy, but I would say this is readable. You can start reading it. Now the sidebar there actually makes the area a little bit constrained. I agree with that as well. But so the point is, because we have the technology, we could observe longer, and we could actually now identify a new need. Actually, the adaptation that we did is probably not perfect. We have, like, users start interacting with another, like maybe they start interacting more with the sidebar. And so this becomes an interesting, like a living interface that adapts itself according to the needs of users. There are some pragmatic issues with this vision that I have, but this is clearly, this is something, the crowd has driven it into this direction based on the data that we got. The other thing I also want to say is the designer is still in control. So my goal is not to replace designers, but to help them achieve potentially a better user interface and address the scalability that we have, the scalability issues that we have with all the devices out there. Yeah.
In the example with the smartwatch and the phone, where you had the phone serve as a keyboard for the smartwatch, or a similar example where you're using other pairs of devices, are all of these devices individually owned by the user, or do you imagine that some of these devices might be shared? And if so, how do you indicate when a screen should actually be shared and when you don't want to give your private information up to a screen?
So there are lots of interesting questions related to this. So the question was essentially whether this, the interface that I've shown you today, am I envisioning? Yes, I'm envisioning a single user that's operating multiple devices for my XDBrowser currently. That's the use case that I'm taking. Embedded in my vision that I showed you is encoded the idea that it could also be multiple users operating multiple devices. Now that does require a little bit more extensions to the prototypes that I'm creating right now. We need a user concept. I've done this in some toolkits. It has interesting issues that we need to solve. But so there is research specifically into collaborative web search interfaces, for example. And so we could apply some of these techniques maybe here. For now, my vision was with XDBrowser, a single user sharing, using multiple devices, sharing between devices. But at the same time, it is also easy with the techniques to actually share an interface from my browser to James's browser, and he could be the next single user owning multiple devices. But the actual really collaborative aspect to it, I haven't explored right now in this. But there's research on that. Yeah.
So a different version of some of Hal's question. One of the classic tensions in adapting automatically interfaces is like a designer has ownership over it, and they feel really, and they don't really like, for example, Hal doesn't really like how it got adapted this way or that way. In the most recent stuff you're doing, where the crowd's pushing it, it seems like maybe one of the opportunities going forward is to then feed that back to the original designer to let them do something there.
Yes, and I hope that I wanted to make this point that even if you're not pleased with the specific interface that you get as a designer, you now have at least data that speaks for it, that at least you need to do something about this interface. I can observe, like, when a new smartwatch or a new device appears on the market, I'm getting kind of weird data. Why do people start interacting in this way? What's wrong? There's a new device on the market. OK, it just happens every week anyway. So then we kind of can start using this data. And that's what I meant by leveraging the data that we collect. I want to build new tools that allow designers to make use of this data. And visualization is one aspect, but really, it is really also to make use of the data, for example, as I did when we formulated a new adaptation rule using the data that we collected. So yes, I'm really going towards this. Yeah, Jeff?
Yeah. So part of your work deals with the underlying infrastructure for implementing these things, and you showed examples of prototyping of a wide variety of cross-device interactions in different contexts. And so I'm wondering, if you look forward to a future where professional software developers are going to be building cross-device applications, what are some of the lessons you learned for how we have to extend our notions of UI toolkits? So any things we do to rethinking how we structure user interfaces?
OK, so that's a very good question, and that's because I wanted to make this point. I've addressed the issue at different levels. For this talk, I've mostly focused on the user interface level. In terms of toolkits, what was in XD Studio, which is more like a design tool, but behind it is also a toolkit, and we have a programmatic approach to creating cross-device interfaces, XD Session. One aspect there is clearly we need a notion of multiple devices. It's like I'm not just designing for this one device, one user kind of, so we need to extend our notion of context models. If you look into the literature, the common context model usually is like, who's the user, what's the platform that's involved in the interaction, what's the environment. But it's not who are the users, what are the devices, and maybe in which environment. And so what we did encode into XD Studio and XD Session specifically is ways of communicating between devices. So that's something you want to abstract, you want to just have in these toolkits. This just should be there. Also, a big issue is still how do you find these devices, how do you connect to them, but once you have, then how do you actually exchange interfaces? And then the other big question, how do you actually keep them synchronized? And what I've also seen a lot is like, it's not that, and we've seen most of these synchronized cross-device experience in research, but when I did my study with users, there's a lot of need for asynchronous cross-device working, where you actually want to be able to quickly cut the connection, do something individually, and rejoin, remerge these once you're done. And so we actually need to be much more flexible when we create these interfaces. I think that's one of the takeaways from the study that I did with users. The other one is like, there was not a lot of agreement for a particularly good cross-device Gmail interface. It really depended on the task, on user preferences, and things like this. What tells me is that even in the future for designers, it will be difficult to anticipate all of these. So we need to make it possible for users to actually easily configure the cross-device experiences.
OK, let's thank Michael. Oh, sorry. Did we have another question, or should we?
Yeah. Do you see a role for machine learning in all this in the future? And if so, what would it be?
OK. Thank you. So do I see a world or a need for machine learning in this? So another way, I was want to ask whether, why do I need crowdsourcing? We have machine learning, right? So I would say I think it is again in line with this mixed initiative. Like right now I'm heavily pushing the user side. I want users to become involved. I want crowds to form a part of the design process. and this helps me address scalability in some sense. But I do realize that some of this, the more I learn about what the users wants, the more I can build more automated kind of machine, the more I can learn from this data. My current take on this is, though, I want to create the data that's useful for designers to work with. I started in adaptive user interfaces, and there are some really good solutions, like Supple is a really good automatically generated user interface. But I don't think that the goal is to really, in the end goal is not to give everything to the system, but to find this good agreement somewhere in the sweet spot between the designer, as in the system, the user, and maybe also the crowd to make use of this data. It's a kind of like a vague answer, but I think they need to connect in some sense. So for the work that I'm doing, I don't see the need for machine learning, but sometimes it would help when you need to deal with a lot of data. So yeah. And actually, or maybe I should phrase it differently. I have experienced, like, when it comes to some of the, like, it would also be interesting if we, rather than ask lots of crowds to generate this kind of touch interface from lots of interaction data that we've observed, could we learn a model from this? And could we actually apply this, from what we've learned from this website, to another website, right? For the same genre. When it comes to these questions, I think machine learning is very powerful. And so this is one way to connect to this kind of research. Yeah? Thank you. OK, cool.